Welcome to part 2 of the screencast series, Introduction to Using Pure Data. We left off with a simple patch here with an oscillator going into the standard output DAC and a slider input for controlling the frequency of the oscillator, overriding the parameter that we had passed earlier. Let's take this a step further. Mix things up, learn about some more objects and signals and things like that. So I'm going to set this slider aside because I find it rather tedious to have to slide this up and down to make notes. So instead, let's try something else. I'm going to put a new object down, and it's called random. And typically you pass a parameter to random, which is the top of the scale, or the top of the range, I should say. So this says, give me a number between 0 and 1,000. Now, random, the object doesn't just randomly output numbers. You have to tell it to. I'm going to open the help here so that you can see this demonstration, and there's a special signal being used here called bang, and I'm going to click this and you can see we're getting random numbers in this number box here. The bang is a special kind of control signal. There's an input for it. It's called bang right here. I'm going to put one down and connect it to the left input of random. The right input, according to the help, is the top of the range. So if we wanted to, say, take this vertical slider, we could put it in here and set what we wanted that range to be. Now if I hit this bang, nothing happens. I don't see anything. Random is trying to output numbers out of this output, but we don't get to see them. So I'm going to add one more object called print. And now I'm going to go out of edit mode so that I can use this bang thing, because when I click it, nothing happens right now. Edit mode, which again, for the rest of this screencast, I'll be using Control E to toggle edit mode. So now I click bang, and behold, there's a random number going into the console here in the main window, which is what print does. So there's our random numbers. Now again, using the mouse to control this is a bit tedious, so let's automate this. I'm going to get rid of this bang for now and add yet another object. This one is called metro, and it's a metronome, and it outputs a series of bangs in time with a given interval. And I'm going to set the interval, it's in milliseconds, so this would be 1/3 of a second. And I'm going to connect the output of the metro object to the input of the random object. And metro, once again, needs a cue. This time it's not a bang, but a control signal generated by the toggle input, which looks like that. So now, when I click toggle, you can see every 1/3 of a second we get a new random number. So let's go ahead and connect the output of random to the input of the oscillator and turn our DSP on. And there you have it, a mainframe computer from a James Bond movie. And I could take this slider and send it to the right input of the metro object, which controls the period. So with a smaller number, we get a faster period. With a larger number, we get a slower period, or larger period. So I'd like to take this opportunity to point a couple things out. One, the output of the metro object and the random object, the slider and the toggle inputs, are all control signals. This is in contrast to the oscillator object, which outputs an audio signal. And again, that's denoted by this tilde, which is a convention used in the PD community. So if, for example, I took that print object once again, and I connect, again, the output of the random object, you can see it prints. These are control signals that we're seeing here. If I try to connect the output of the oscillator object to the print object, no dice. Can't connect a signal outlet to a control inlet. That is because the audio signals are running at a much higher sample rate, far beyond the capacity of any control signal object. If Pure Data tried to print out all the values coming out of the oscillator object, it would flood my screen and probably make my computer crash. So there's this internal division in the system that differentiates these two kinds of signals, and it's really just about the sample rate, so that the DSP can operate efficiently. So be aware of that when you're building a patch, that you may end up in a situation where you can't do what you thought you were going to be able to do, because one signal is an audio signal, whereas the other is a control signal. Some objects only work with control signals, whereas other objects only work with audio signals. Conveniently, a control signal can be sort of interpreted freely as an audio signal. So the left input of the oscillator object is actually an audio input. If we go to the help, you can see that right here is a demonstration of the fact that the left input can accept a signal. This is the recommended way to convert a control signal into an audio signal using the sig tilde object. So keep that in mind. I'm not using this sig tilde object in this particular example. It's not. It's only important in certain situations to do that. So let's take this patch a step further. Let's add a compositional element. Let's make it so that we can actually sort of program a melody into it or something like that. So to do that, I'm going to wipe this away and introduce a new thing, a data type called an array. I'm going to set it to just a small value. If you've ever done any programming, you may have heard the term a data type called an array. An array is a collection of values. You can think of it as a table or a list, and you will see that very soon when I have this set up. So there's our array. It's called array1, and if I go to the properties, I'm just going to cancel this. It opens two windows. I can go to Open List View in the Array Properties window, and you can even see here that it's a list of values. I'm just going to enter in some random numbers here just for fun. 100, 200, 300, 400, 500, 600. Note how the line we saw is no longer on the screen. That's because we have to set the range of the array, the display of the array. So I'm going to go back to the properties. There are two boxes that pop up when you edit an array. There's the array properties and the canvas properties. They end up in different windows. It's a little confusing, but you'll get the hang of it. So in the canvas properties of the array, there's an area to set the range of the display. So I'm not interested in negative values. So in the y-axis, I'm setting the bottom to 0 and the top to 1000. And there we have our values again, displayed as these sort of points or sort of bar graph things. So that's pretty cool. It graphs them for you. You can see it visually. It's very convenient. So that's set up. So I'm going to leave that there. So here's our array of values. I just put in some random ones. And if I go out of edit mode, you'll see I can even slide these up and down and set them to whatever I want, which is also very cool. You will note that if you click in this area, at least in the versions of PD running in Linux that I've used, nothing happens. You have to actually click the far left spot on the line. It's a pretty annoying bug. So just for your information, if you want to change these, click this little spot on the left side here and drag. So yes, and then the last one, that trick doesn't work. Ha ha ha. The most reliable method I found is to go to the one to the left of it, drag it, click drag, and then move your cursor to the right, and then it will be under the control of the mouse. Pretty bad bug, in my opinion. So, moving on. So here's our array. How are we going to read from it? Let's use an object. It's called tab read, which is short for table read. Let's put a number input. Oh, there you are, here. And what this will do is set the index. Which one of these we want to read. So if it's 0, it will be this one. If it's 1, it will be this one. 2, this one, etc. I'm going to use another number object, which, by the way, can output a number, which is pretty convenient. So you don't have to use print to see the output. So here we go. Out of edit mode now. Oh, I forgot to pass one very important parameter to tab read, and that is the name of the array. There we go. Alright. Ah yes, and if you'll pardon me while I change the name of this, because I have another one open, which, by the way, you may encounter this. If you have two of the same, if you have two arrays with the same name, there will be problems. Okay, where were we? So now, as I set the number index input to tab read, it reads out the values of the elements in this array. And so, for example, if I set this to a high value, I can also type a number into number, hit enter. That's actually 0 that I want. The first one is 0, the 0th element. And then I set it to very low value. I hit 0, enter again. There we go, 64. 64 down here. And almost 1,000 up here. So that's cool. Now let's automate this. We want a counter to automatically increment the index input of tab read. Now this is going to get interesting. I'm just going to warn you. Pure Data doesn't have a counter built into it natively. There's no primitive counter object. So for the sake of demonstration, I've come up with a pretty good method of cycling through these elements of the array using a different kind of counter, an audio counter. It's called a phaser. It ends with a tilde. And the phaser object outputs a what I would call a sawtooth waveform. You can see a demonstration of it here. If I turn this on here in the help file, there's a cool little oscilloscope that shows you what the waveform looks like. So it climbs from 0 to 1 and then drops down, just like a counter cycling over. So if we multiply that value by 6, it will scale between 0 and 6 over and over again, just like a counter, just like we want. So I'm going to set it to 1 hertz, and then I'm going to replace the tab read object with tab read tilde, which is it just happens to be a tab read version that works in audio signals. Not every object has a tilde cognate counterpart. Tab read does, which is convenient for this particular scenario. So again, the phaser, as you saw in that oscilloscope, is only going from 0 to 1, so it would just bounce back and forth between these two elements in the array. So we want to multiply that with the multiplication object, the audio version of the multiplication object. So times 6. So we pass the phaser output into the multiplier and then into tab read. I can't show you what the output of tab read looks like with the number object anymore, but I think you get a pretty clear idea from that help oscilloscope thing. So when I connect this, you get it plays the pattern. So I can go into this array and change the values like a step sequencer on an analog step sequencer. So there you have it. It's a basic step sequencer synthesizer patch using Pure Data. This is a pretty fun little toy. I bet you could, sit here for at least 4 hours just twiddling these back and forth. At least I could. You can of course also add more elements to the array. going into the properties, and not in the canvas properties, but in the array properties, setting the size to a bigger number. You could make this 16, for example, and then you would increase your multiplier to accommodate all of those extra elements. So there it is, simple baseline synthesizer sequencer in pure data.